Welcome to 4.6, graphs of other trig functions. So we're going to talk about tangent graphs and secant, cotangent, etc. So our central question is, how do you graph a tangent, cosecant, secant, and cotangent function? So the graph of tangent. In this case, your period is just pi. So in the other two that we talked about, sine and cosine, it was 2 pi. This one's just pi. So the tangent function is an odd function. And the tangent function is undefined when x equals pi over 2, or any multiple of pi over 2. That means it will not touch it. So it's undefined, which means it cannot touch it. So your period's pi, your domain is all real numbers except odd multiples of pi over 2. And your range is all real numbers. You have a vertical asymptote at the odd multiples of pi over 2. So that would be pi over 2 times 3, so 3 pi over 2. Don't have even because it would simplify to not pi over 2. You have an x-intercept occurs midway between each pair of consecutive asymptotes. So between negative 5 pi over 2 and negative 3 pi over 2 is your x-intercept. So graphing your variations. It's the same format as we had before. So find two consecutive asymptotes by finding the interval containing one period. A consecutive asymptote occurs, so you have bx minus c equals negative pi over 2 and bx minus c equals pi over 2. So you're going to set your bx minus c to negative pi over 2 and pi over 2. So identify an x-intercept, which is midway between there, and then find your points on the graph that are 1/4 and 3/4 of the way there, and then graph all of your points. We will go over an example. It sounds a lot more confusing than the actual map is. So, the blue is our line. We have your x-intercept, which is midway between your two asymptotes. And it just tells you how to find your two asymptotes and then your midway points. So let's look at an example. So we have y equals 3 tangent 2x. 4 between that point. So a is 3, b is 2, and c is 0. So step 1 is to find two consecutive asymptotes. So that means you have 2x. If I did minus c, that's just going to be 0, equals negative pi over 2, because that's our rule. So you can set it like this, or you can set the 2 equal. I'm just going to set it as 2 equal. It's doing the same thing. So you have to set it to negative pi over 2. So I divide both sides by 2. Now I also have to set it to positive pi over 2. So one period is between negative pi over 4 and pi over 4. So you have an asymptote at negative pi over 4 and you have an asymptote at pi over 4. So step 2 is you want to identify the x-intercept. So your x-intercept is midway between negative pi over 2 and pi over 2. So if you were to go halfway between those two things, it would just be 0, 0. So your x-intercept is 0, 0 in this case. You can draw it on a number line if you want. If you already have a graph, you can find out which one's midway. In this case, it's just 0, 0. Step 3, you want to find the points on the graph that are 1/4 and 3/4 the way between your consecutive asymptotes. So these points have a y-coordinate of negative a and a. So you're going to set your equation. So you're going to set y as -3. Remember, a equals 3. So -3 equals 3 tangent 2x. But then you also have 3 equals 3 tangent 2x. You need to solve both of those. So divide both sides by 3. So if you go now back to your table and you look for -1, so you'd have to go and look through the table that you had from previous, and you want to see when does tangent of something equal -1. So you're going to have 2x equals -pi over 2. Oh, I should have read that the other way. So tangent equals -1, and you have -pi over 2. And tangent equals +1 when you have pi over 2. This is just by going back and looking at my chart of when it equals -1 and 1. So divide by 2. Ran out of room. No, this should be 4. Oh, I'm sorry. So you're going to have a point that's -pi over 8, -3. And you're also going to have the point pi over 8, 3. So you have your asymptotes, you have your quarter and your 3/4 way, and you have your midway. So now you'd be able to graph it. So we have our midway between our two asymptotes. And your quarter and 3/4 way. And then you would just repeat it one step over. So your cotangent curve. It has the same period, it's pi. Your domain is all real numbers except the integral multiples of pi. So instead of pi over 2, it's just pi. And your range is all real numbers. Your vertical asymptotes occur at your integrals of pi. Your x-intercept is midway. It's also an odd function with origin symmetry. So at your origin, it is symmetric. And points on the graph at quarter and 3/4 are between your asymptotes. So we're going to solve it almost the same way. The only difference is find 2 consecutive asymptotes by the interval, but you're going to have 0 and pi this time. So this is a diagram of your cotangent. So coordinate A, -a, x-intercept is part way, and then it tells you how to find them. So let's do an example of this one. So A is 1/2, B is pi over 2, and C is 0. So step 1 is to find your consecutive asymptotes. So this time I'm going to solve it in inequality format. So you want bx minus c. Well, we don't have c, so it's just going to be pi over 2 x, or bx. So you want to multiply both sides. We're going to multiply both sides by 2 to get rid of our 2, or all 3 sides, I should say. So 0, pi x, 2 pi. And we still need to get rid of pi, so we're going to divide everything by pi. So 0 and 2. So we have two consecutive asymptotes at 0 and 2. So 1 period, 0, 2. So if I have an asymptote at 0, asymptote at 2, your x-intercept is going to be midway, which is 1. So your x-intercept is going to be when x equals 1. It's halfway between 0 and 2. So now we have to find our coordinate that is 1/4 and 3/4 through. So you're going to have negative 1/2 equals 1/2 cotangent pi 2. And then you're going to have 1/2 equals 1/2 cotangent pi 2x. So pause the video and see if you can solve this one on your own. Alright, so when it equaled negative 1/2, you should have gotten 3/2. And when it equaled 1/2, you should have gotten 1/2. So the tricky part for me normally is when I get to this point. But you need to go and look at your chart, or you need to go and look at your unit circle and see. So when cotangent is pi/2, or when cotangent equals 1, and then solve. And cotangent equals negative 1. So if you graph your points, this is what your cotangent will look like. So make sure you complete the questions below and then watch the next video. Next video we're going to talk about graphing cosecant and secant functions.